Are you confused with mean, variance, and standard deviation? Here is a video that shows how to calculate and interpret mean, variance, and standard deviation with real-life example.
Mean, variance, and standard deviation turn raw numbers into actionable insights. They tell you the average result, the risk/spread of the data, and how predictable future outcomes will be. This can be learned with an example. Consider a dataset: 4, 8, 6, 5, 3, 7. 1. Find the mean. The mean is the average of all your data points. Add all the numbers together and divide by the total count of numbers. Calculation: 4 plus 8 plus 6 plus 5 plus 3 plus 7 divided by 6 equals 33 divided by 6 equals 5.5. 2. Find the variance. The variance measures how spread out the numbers are. To find it, subtract the mean from each data point, square the result of each, and then find the average of those squared differences. Calculation: equals 4 minus 5.5 squared plus 8 minus 5.5 squared plus 6 minus 5.5 squared plus 5 minus 5.5 squared plus 3 minus 5.5 squared plus 7 minus 5.5 squared divided by 6 equals 2.25 plus 6.25 plus 0.25 plus 0.25 plus 6.25 plus 2.25 divided by 6 equals 17.5 divided by 6 equals 2.92. 3. Find the standard deviation. The standard deviation is simply the square root of the variance. It tells you how far, on average, the data points are from the mean. Calculation: equals square root of 2.92 equals 1.71. Here is the interpretation. The mean 5.5 tells us that the average value of the dataset is 5.5. It represents the center of the data. The variance 2.92 tells us that the data has a moderate spread around the mean. The standard deviation tells us that the values typically lie about 1.71 units away from the mean of 5.5. Real-life analogy. Imagine 5 students walking to school. Individual time taken by them in minutes are 17, 19, 20, 21, 23. Mean: 20 minutes. Variance: 4. Standard deviation: 2 minutes. Mean: the average walking time is 20 minutes. Variance: measures the squared differences in walking times, useful for mathematical analysis, but not very intuitive. Standard deviation: if the standard deviation is 2 minutes, then most students take about 20 plus or minus 2 minutes, roughly 18 to 22 minutes. Other examples. In finance and investing, investors use these metrics to balance their returns against financial risk. Mean represents the expected average return of a stock over time. Variance and standard deviation represent market volatility and investment risk. Practical example. A stock with a high mean return but a high standard deviation is a high-risk, high-reward investment. A stock with a low standard deviation offers stable, predictable growth. 2. Manufacturing and quality control. Factories use these formulas to ensure products are consistent and free of defects. Mean represents the target size, weight, or volume of a product. Variance and standard deviation measure how much the machine's output varies. Practical example. If a machine fills cereal boxes, a high standard deviation means some boxes are overfilled, wasting money, and others are underfilled, causing legal issues. 3. Sports analytics. Coaches and scouts use these metrics to evaluate player performance and consistency. Mean shows a player's scoring average per game. Variance and standard deviation measure the player's consistency. Practical example. A basketball player who scores exactly 20 points every game has a standard deviation of 0. A player who scores 40 points in one game and 0 in the next has the same mean, 20, but a massive standard deviation, making them unreliable. See you in next video. Subscribe for more.